Right now, roughly 217,000 Americans are locked inside a window of time they did not choose. There is no mainland behind them. There is no highway out. There is no neighboring state to drive to when the sky turns black. There is only ocean. 3,000 miles of it between them and Hawaii. 1,300 miles between them and Japan. And tonight, something is moving across that ocean toward them. Its name is Sinlaku. It is currently the strongest storm on planet Earth. Not the strongest in the Pacific. Not the strongest this season. The strongest on Earth. Full stop. But this is not a script about a single storm. Because at the exact moment Sinlaku reached its peak intensity, something else happened in the same archipelago. Something underneath. Something that nobody is connecting to the storm above. And once you see how those two things line up on a map, you start to understand why this event does not have a clean name yet. Stay with me, because before we get to the part nobody's talking about, I need you to understand what is actually bearing down on these islands right now. Before we go deeper, drop a comment with your location and your local time. I want to know where in the world you are reading this from as we walk through what is happening in the Pacific tonight. Super Typhoon Sinlaku formed on April 9th, 2026, from a low-pressure system roughly 234 nautical miles west-southwest of Chuuk. For the first 24 hours, it was unremarkable. A tropical depression. The kind of system that forms in the western Pacific and usually dissipates or drifts harmlessly into open water. Then, on April 10th, it reached typhoon status. 2 days later, on April 12th, it was a Category 5 equivalent with sustained winds of 185 miles per hour. Let me put that number in context. There is a list of every known typhoon in the northwestern Pacific that reached Category 5 strength between January and April. The entire list. Going back to the 1950s, there are 10 storms on it. 10. In more than 70 years of modern weather records, Sinlaku is number 3 on that list. Only one typhoon in the historical record has ever been this strong, this early in a calendar year. Super Typhoon Hester on January 1st, 1953, 73 years ago. And the gap between Hester and everything that followed was so wide that meteorologists treated it as an outlier for decades. Sinlaku has now closed that gap. The Japan Meteorological Agency classifies Sinlaku as a violent typhoon, which is the highest intensity category on their scale. The Joint Typhoon Warning Center clocked it at 150 knots. And satellite imagery from the VYYRS instrument aboard the Suomi NPP platform captured something else, something you rarely see. Gravity waves, concentric rings propagating radially outward from the storm's eye, visible in the mesosphere. The mesosphere sits between 50 and 85 kilometers above the surface. Sinlaku lives in the troposphere, which only extends to about 12, which means the storm was pushing so much energy upward that it was literally disturbing a layer of atmosphere more than 30 kilometers above where it exists. You do not see that from ordinary storms. You see that from storms that are operating at the upper bound of what the atmosphere is physically capable of producing in that region at that time of year. And that is the first anomaly. But that is only the first layer of the problem. Here is what almost nobody is reporting. At 11:47 local time on Sunday, April 12th, the same day Sinlaku peaked at 185 miles per hour, a magnitude 5 earthquake ruptured near Pagan Village on Pagan Island in the northern Mariana Islands. Same archipelago, same day, same hemisphere. The quake was not a coincidence of scheduling. It was the latest in an active seismic sequence along the Mariana subduction zone, the tectonic boundary where the Pacific plate is being driven westward beneath the Philippine Sea Plate at a convergence rate of several centimeters per year. This is the system that created the Mariana Trench. It is the system that created the islands themselves. And it is the system that created what geologists call the Arc of Fire, a chain of roughly 21 underwater volcanic sites, plus active surface volcanoes at Pagan, Anatahan, and Agrihan. Pagan has erupted before. So has Anatahan. So has the seafloor around them. Now, hold that picture in your mind. A Category 5 typhoon is approaching from the south, producing maximum significant wave heights of 12.8 meters. That is 42 feet of water moving through a subduction zone that is already seismically active, directly above one of the deepest ocean trenches on Earth. The physics here matters. So let me walk you through it. When a tropical cyclone of this magnitude passes over a coastline, it generates what atmospheric scientists call pressure loading and unloading. The storm's eye is a region of extremely low barometric pressure. As it moves, it literally lifts the ocean's surface beneath it, a phenomenon known as the inverse barometer effect, and then drops that mass back down as the eye passes. On top of that, the wind field generates surface currents, storm surge, and wave action that transmit kinetic energy down through the water column. In deep ocean trench environments, that energy does not dissipate the way it would over a continental shelf. It couples with the seafloor. Pore pressure in the sediment changes. The stress field across fault surfaces shifts. These are small effects on any given day, but they are measurable. And they are well documented in the peer-reviewed literature on what is called hydrologically triggered seismicity. The question, the one nobody on cable news is asking tonight, is whether a Category 5 typhoon passing directly over a trench system that just produced a magnitude 5 earthquake within the last 48 hours can act as a loading event on an already stressed fault. Is this a coincidence? Or something else? Let me know in the comments, because I want to hear how you are reading this. Either way, what I can tell you is this. The Mariana subduction zone is considered weakly coupled. The historical literature notes that despite extremely high convergence rates, great megathrust earthquakes of magnitude 8 or larger are rare here. But rare does not mean impossible. And weak coupling does not mean the fault is quiet. It means energy is released more often in smaller, distributed events, the kind that can be nudged by external forcing. Nobody is predicting a megathrust tonight. I am not predicting one. But the compound hazard framework, the idea that independent systems can stack on each other, does not require a megathrust to produce a catastrophic outcome. It only requires two events in the same place at the same time that the emergency model was not built to handle together. And that is exactly what is happening right now. Keep that thought. We are going to need it. To understand how Sinlaku got this strong, this early, you have to understand ocean heat content. Tropical cyclones are heat engines. They draw energy from the upper layer of the ocean, specifically, the layer that sits above 26 degrees Celsius. In a normal April, the western Pacific warm pool is still in its cool phase. Surface temperatures are warming, but have not yet reached the deep reservoir state that fuels the traditional summer typhoon season from July through October. Sea surface temperatures across Sinlaku's track this week exceeded 29 degrees Celsius. Not at the surface alone, down through the mixed layer. That is summer water in April. When a storm encounters that kind of thermal reservoir and low wind shear overhead, it undergoes a process called rapid intensification. The formal threshold is an increase of at least 35 miles per hour in sustained winds over a 24-hour period. Sinlaku blew through that threshold. It gained roughly 60 miles per hour in intensity in under 48 hours. That is not unusual anymore. That is the new pattern. The peer-reviewed climate literature has been documenting, for the better part of a decade, a statistically significant increase in the frequency of Category 5 storms globally since 1982, the year accurate satellite coverage became available. That trend is significant at the 99.5% confidence level. Meaning, in plain language, there is effectively no chance it is random. What the data does not tell you yet, because the data is still being collected, is how early in the year this threshold can now be crossed. Sinlaku is a data point in that emerging record. And it is not a small one. But there is another part of the machinery that almost nobody discusses. Geography. Saipan, the capital of the northern Mariana Islands, is roughly 3,300 miles from Honolulu and 3,000 miles from Sydney. The Commonwealth consists of 14 islands spread across 264,000 square miles of open Pacific. The total land area, all 14 islands combined, is 176 square miles. That is smaller than the city of Houston. When a storm of this size passes over geography like that, there is nowhere for the population to disperse to. Saipan is 12.5 miles long, Tinian 39 square miles, Rota 33. These are not places where you drive inland. There is no inland. There is coastline on every bearing. 99% of the population lives on those 3 islands. 90% lives on Saipan alone. And the forecast rainfall totals near the storm's center are 15 to 25 inches. In some zones, higher. That is rainfall totals you would associate with a landfalling hurricane in the continental United States, delivered onto a limestone and volcanic archipelago with limited drainage infrastructure, rising terrain, and a population density of roughly 242 people per square mile. This is the machinery. This is how the event is assembled. Storm, ocean, geography, seismic zone. 4 independent systems overlapping in one place at one time. And that brings us to the part of this story that is hardest to talk about. Guam and the Northern Mariana Islands are U.S. territory. The residents of Guam are U.S. citizens. The residents of the Commonwealth of the Northern Mariana Islands are U.S. citizens. They vote in presidential primaries. They serve in the U.S. military at higher per capita rates than most states. They pay federal taxes. If a Category 5 storm with a magnitude 5 earthquake inside the same 48-hour window were bearing down on Miami, or Houston, or San Diego, there would be wall-to-wall national coverage. There would be presidential statements. There would be cable news anchors broadcasting from seawalls. There is not. Run the search yourself tonight. See how much space this event occupies in the national news cycle compared to what a mainland event of equivalent scale would generate. The gap is not small. It is an order of magnitude. I am not going to speculate about motive. I am going to tell you what is measurable. The Mariana Islands sit inside a coverage pattern in which distance from the mainland correlates with attention in a way that is not explainable by population alone. Puerto Rico experienced this in 2017. American Samoa experiences it regularly. Guam experienced it in 2023 with Typhoon Mawar. The pattern is consistent across administrations, across networks, across decades. When the event is far, the attention is small. When the event is close, the attention is total. And here is the consequence of that gap. It is not just emotional. It is operational. Federal disaster response resources are allocated in part based on political pressure, and political pressure is generated in part through media saturation. When a population of 217,000 Americans receives proportionally a fraction of the national attention that a mainland population of the same size would receive. The downstream effects on aid timing, supply pre-positioning, and reconstruction funding are real. They have been documented by GAO reviews. They are not theoretical. So when we talk about Sinlaku as a storm, we are only talking about half the event. The other half is the information system that decides which disasters the country pays attention to. And that system, tonight, is underweighting this one. That is not a conspiracy. It is a pattern. And patterns can be measured. Here is where it all converges. Modern emergency management, in the United States and globally, is organized around discrete hazard categories. Hurricanes are one agency. Earthquakes are another. Volcanic eruptions are a third. Tsunamis are a fourth. The frameworks were built in the 20th century, and they were built on an assumption that these hazards occur independently, or at least sequentially. That assumption is breaking down. The scientific literature now has a phrase for what is happening. It is called compound hazard analysis. The idea is that when two or more independent hazards overlap in space and time, the resulting risk is not additive. It is nonlinear. The total damage is not hazard A plus hazard B. It is hazard A multiplied by hazard B, because each hazard degrades the systems that would normally respond to the other. A typhoon knocks out the power grid. The earthquake response depends on the power grid. A typhoon floods the roads. The volcanic evacuation plan depends on the roads. A typhoon saturates the sediment. The earthquake shakes the saturated sediment. The sediment liquefies. These are not hypotheticals. These are documented failure modes from previous compound events in Indonesia, Japan, and the Philippines. What the Mariana Islands face tonight is a textbook compound hazard signature. A Category 5 equivalent typhoon, an active seismic sequence in the same archipelago, 3 active volcanoes on neighboring islands, a subduction trench directly east, an ocean warmed beyond its seasonal baseline, a population of 217,000 U.S. citizens with no overland evacuation option, and a national attention budget that is not looking in their direction. That is 6 independent stressors, overlapping in one geography, on one timeline. We do not have a clean name for this kind of event yet. Natural disaster does not capture it. Tropical cyclone does not capture it. Seismic event does not capture it. The scientific community is still building the vocabulary. And that vocabulary gap matters, because you cannot plan for something you cannot describe. The real story here is not Sinlaku. The real story is the distance between what we are now capable of measuring and what we are actually prepared to respond to. That distance is growing. It is growing faster than most people realize. And the Mariana Islands, tonight, sit inside it. Before I end this, I want to return to the 217,000 people I mentioned at the start. They are, right now, watching the sky. Some of them are in shelters. Some of them are in homes that have survived previous storms and are hoping this one does the same. Some of them have power. Some of them do not. Some of them have lost cell service already. The storm's closest approach to Saipan and Tinian is happening in a window that is measured in hours, not days. When the sun comes up over the Pacific in a few hours, the world is going to learn what kind of night they had. The physics will keep working whether or not we are watching. The subduction zone will keep releasing stress. The ocean will keep absorbing heat. The atmosphere will keep producing storms that our frameworks were not built to handle. These systems do not wait for our attention. But the people inside those systems do. If this is the first time you have thought carefully about what is happening in the northern Mariana Islands tonight, that is not your fault. The coverage gap is real. But now that you know, you can watch this story differently. You can notice which networks cover it and which do not. You can notice how the death toll, whatever it turns out to be, is reported compared to how it would be reported if this had happened in Florida. You can notice whether the compound hazard framing ever makes it into the mainstream narrative, or whether it gets reduced, as it usually does, to a single word. A typhoon, a storm. It was never just a storm. If you want the next layer of this story, the one that goes into the 1953 Hester event, the only typhoon in recorded history to reach this strength this early in the year, and what its legacy tells us about what Sinlaku may still become, I have put together a follow-up that picks up exactly where this one ends. Until then, stay with the people in its path. They are the story. Everything else is framework.